Hello everyone, this is Kyle Miller, Solutions Engineer at DJI. And today we're going to be talking a little bit more about 3 different industry verticals, all within the geospatial industry. The first one we'll be talking about is land surveying. Secondly, we'll be following up with natural resources, including forestry. And finally, we'll be wrapping things up with precision agriculture. With that, we're going to be talking about 5 different things within each of these industry verticals. We're going to be starting off with an introduction about that industry, some of the challenges that the personas within the industry have. That may be the very first one with land surveyors. We look into natural resources and the different roles and responsibilities within forestry management. Then we get into the workflow. What is the typical daily life of some of these personas, and what are some of the challenges that they have within the typical workflow when they go out and capture data? Then we'll be finishing up a bit with what DJI can provide and the use cases within the drone ecosystem. So how do we be able to leverage DJI drones in our solution across the different use cases within each one of these industry verticals? Let's go ahead and get started with land surveying. An introduction to land surveying. The land surveying are fundamental techniques used to gather, analyze, and represent spatial information about the Earth's surface. Mapping involves creating a visual representation of the Earth's features, while surveying focuses more on accurately measuring and documenting those features. One of the other fun little facts about surveying is there are over 50,000 certified land surveyors in the United States. As we look into a typical land surveying project lifecycle, so this might be a typical surveyor or a surveying firm. Typically, it's going to be looking at pre-bid, where they're going to be bidding on different surveying projects and understanding what that job would entail. Then if they get the bid, it would be capturing of that data when they're actually on site and the different responsibilities there, and then data processing. So getting out of the field, what are the different responsibilities from surveying to a GIS professional that to get the actual deliverable to hand over to the client. Within these specific responsibilities, we'll be talking a little bit later about the use cases that drones, specifically DJI, can provide on each one of these responsibilities. Some of them, drones can be more beneficial than others. Also, let's take a look about some of the personas within surveying. So these are industry individuals that may benefit from drone use, whether it being the true surveyor, boots on the ground. It may be a GIS or a CAD technician that's going to be post-processing all of that captured data and getting that deliverable. There's also the project manager. So someone that is keeping track of the entire site. Their main goal may not be surveying, but they at least need to know about what's going on surveying-wise. There's also the landowner that also needs to keep track of what's going on survey-wise, and the potential business owner if that's different than the landowner. Next, let's talk a little bit about some of the challenges that these personas have, trying to figure out the responsibilities that we talked about earlier. So what are some of those challenges that surveyors may have? First off, the time and the energy consumption on site. Depending on that type of survey, it may take hours, it may take days, it may take weeks to be able to get over the entire site with the required density that it may take. So if we're walking around with a traditional base station and we're dropping a point, that may take a very long time if we're covering tens or hundreds or thousands of acres for an individual site. It's also very difficult to achieve those dense data sets, whether it's marking each point and getting it point by point, or setting up something that's very sophisticated that can capture dense data, but is very difficult to move around the site and the scene. There's also challenging environments. You're working out in the heat, the cold. You may have snow that may be impacting as that survey as well. You may just have dense vegetation. Whatever that scene may be, intense slope, intense grade, we're going over some very extreme environments. Also, the data turnaround time. This can be very important as we look at active job sites, especially construction focused, where things are happening daily, where we need to make sure that we're on track. So being able to get quick turnaround times on very hard to get data at times can be a challenge. Now let's talk about the workflow that some of these registered surveyors and other CAD and GIS technicians have when they are going out and capturing that data. So a surveyor may use equipment such as a traditional base station to capture the entire site. Oftentimes that can be on foot or using some sort of ground-based vehicle, which can be a bit difficult to get to all of the site. It also just takes measurements one spot at a time. Obviously, if you're looking at total stations and things that are going to be laser scanners, you're capturing more than one spot at a time. But wherever you are setting up, from there you're getting one perspective. So that can be a challenge when you're trying to get multiple perspectives and dense data over the entire site. Also, data processing. Surveyor exports log points and then processes those points in GIS or CAD software, and sometimes that software is very cumbersome. It does take a decent amount of training to work with some of these different GIS platforms. The benefits of utilizing drones for surveying. That can be definitely a wide variety, but first just being able to cover that land very, very quickly and capture very dense data. So we're going to have safer work environments where we can oftentimes stand in one location or a few centralized locations and not have to trek to these very dangerous locations to be able to mark points. We're having the drone fly over them and mark them for us. It can be scaled for pretty much any project. As you get to those dozens or hundreds or 1,000-acre job sites, you can really get drones to still be able to cover that. Also, the data quality. Drone data is typically going to be more dense than most other ground-based methods. Also, data processing can be quick and easy when utilizing a software photogrammetry or LiDAR processing software such as DJI Terra. Next, let's talk a little bit about what DJI can bring to the table for surveyors and within that drone industry. So let's first talk about some of the different considerations for drones and for those payloads when you're looking at surveying. First off, it's going to be drone accuracy and image accuracy. Are you going to be able to either utilize RTK image tagging or maybe even use ground control points on the ground to correct for that? RTK has a lot of different benefits there, as well as having just a GNSS receiver on board. Large sensor size, we're looking at visual cameras. Having a larger sensor means you're going to have a lot more dynamic range, take a much cleaner, crisper image where you may have dark and light points of that image. Also, a high quality shutter. Being able to be very accurate is very important for surveying. And so taking a very accurate image while the aircraft is moving can be a challenge. And utilizing mechanical, global shutters, things like that can help balance out compared to a rolling shutter. Fast trigger speed, something that can cover the ground as quick as possible because time is money, even on surveying. Long flight time, so the longer you can fly, the more area you can cover within a single battery, which is always beneficial. Long transmission range, sometimes these sites, once again, can be dozens, hundreds, or thousands of acres, and we want to make sure that we have connectivity for safe operation during that entire time. Also, being able to get into LiDAR capabilities with dense vegetation. We're not just working with photogrammetry, but we can also work with LiDAR just based off of what the environment wants and what the environment provides. So whether it's a lot of dense vegetation and we need to get a digital terrain model, that is typically going to be best suited for LiDAR. When looking at DJI specifically and what the product lines that we can recommend for surveying, first off, you have the Mavic Enterprise series, something that's going to be the most scalable surveying and affordable surveying solution that DJI Enterprise has, something that's going to be able to tag with RTK, a large sensor size for the platform, as well as a dedicated shutter such as a mechanical shutter. If you are looking for something that's going to be a little bit higher quality, more versatile, you're going to be looking at the Matrice series with the drones that you see on the right-hand side. You're going to be able to switch out payloads depending on what the job site wants. Whether it's for payloads, the Zenmuse LNP series, if you're needing to capture LiDAR or capture photogrammetry, having a very large image sensor and a very accurate laser sensor as well, very beneficial for surveying. And then also you need to look at the different processing engines that can be out there, such as DJI Terra, to be able to take all of this data to get you a deliverable. And finally, let's wrap up with some of the different use cases for surveying. When we talk about the different use cases and we dive back into what the roles and responsibilities are within some of these different personas, here we have pre-bid, capture, and data processing like we saw before, and obviously the different use cases that you can utilize drones for, a number of them within surveying specifically. So the very first case study that we have is a very large area digital model. This is a large city in China that we were able to capture and use multiple batteries here, utilizing the Matrice series of drones and the Zenmuse P series payload to capture high resolution photogrammetric imagery that's also going to be very accurate. So as we zoom in, look at this data, it's going to be, within that inch level accuracy that we really are looking for. Being able to capture very large data sets like this comparative to dropping 1 or 2 points, and you're looking at something that is captured within a matter of hours with very dense data compared to days to be able to capture something with other methods, whether it's ground-based or vehicle-based. Also, part of surveying can be 3D model reconstruction. So heritage modeling, this one was a pretty cool 3D model that we've been able to share around, capture with the Mavic Enterprise series. We also have very sophisticated flight planning features that are built into the controller on our DJI Enterprise products. So you're going to be able to capture with extreme accuracy and autonomy and be able to recreate these within DJI Terra. And for the last use case, we have a glacier documentation project. This one would be very, very difficult and very challenging to be able to capture, especially with extreme density. We're looking at a scene that's very large, very mountainous. Also, it's a scene that is actively moving. So being able to get on top of the glacier is really dangerous. So being able to cover that, not being on foot, being able to cover that from the air, as well as getting the intense density that we need to understand if there's been any movement, so we can document that. You can see even with the Mavic Enterprise series, it was a 9-flight mission and it was processed in a data turnaround time in about 24 hours with data capture and data processing. So quite an intense project showing size, scalability, density, as well as safety features that drones can bring. With that, we'll be talking about our next industry, diving into natural resources. That also includes forestry. Let's take a little bit of an introduction into natural resources. This industry focuses on the well-being of trees, vegetation, and brushlands. Multispectral imagery, topographical surveying, and aerial mapping can help locate these plant disease, plant stress, and navigate and forest officials towards improving their conditions. Surveying for natural resources can also pertain to documenting wildlife and documenting habitats. So it's not just about the actual vegetation that's out there, but also some of the other effects that animals or different habitats may have on that vegetation. So a lot more focused on the natural science side of things, which would make sense. When we look at the different roles and responsibilities within natural resources, we look at site planning, site documentation, and then recovery. Typically, we're not going to be bidding necessarily on these jobs. It's going to be more making sure that they get documented with different funding from state funding or federal funding, and being able to keep up on that. So site planning, you can see the different responsibilities that these personas may have. Also getting into the site documentation, so going out and actually capturing that data of a survey, and then recovery, whatever that next step may entail, whether it's handing off a deliverable for documentation or actually going out and if it's for disaster management or disaster recovery, you can then make actionable decisions based off the drone data. You can see some of the sub-industries within natural resources. We have forestry. We do have precision agriculture. I include that on natural resources just because it's very much plant focused. But we do have a specific sub-industry vertical on precision agriculture that we'll be focusing on next. We also have disaster response and archaeological surveying. When we get into some of the different challenges that they may have, honestly, a lot of these are going to be somewhat similar to land surveying. The time and the energy consumption on site. Also, the very difficult to achieve dense data sets and challenging environments. These environments may be areas that humans have not touched for months, years, decades, hardly ever. So you're going out, once again, it can be dense vegetation with forest, jungle. It can be very mountainous. It can also just be very difficult to be able to walk through or drive through these areas. Also, changing sunlight during capture, a bit more important when we're talking about vegetation, because understanding vegetation and understanding how healthy a plant is can be determined based off of what the sunlight is during the day, and it can be manipulated. So being able to understand an accurate representation of a forest even while the sunlight changes from day to day or week to week. We get into the workflow of natural resources. On site, it's going to be, once again, very similar to land surveying, where you're going to be using equipment like a base station to capture the entire site, oftentimes on foot, and manned aircraft can be very expensive, and budgetary reasons can be one of the reasons why you can utilize drones, that it's going to be more affordable. It also can be taking measurements one spot at a time, extremely remote and often mountainous terrain when we're talking about documentation. Data quality, another aspect that a natural resource mapping engineer may need to take into account. So sunlight changing, we talked about that before. Poor data density when captured by foot. And then also satellite data can have issues with cloud cover, issues with resolution. And so it's really balancing where you're capturing that data from and making sure that it's as accurate as possible. The benefits of utilizing drones, it's going to be safer work environments. Once again, you're going to be able to launch and fly from a safe location and have the drone cover that extremely challenging terrain and environment for you. It can also be scaled to pretty much any project. Data quality, same type of thing. We're getting much more dense data than traditional surveying methods, and that data can be processed very quickly and easily in DJI Terra. Let's talk about the solution that DJI has to offer when it comes into natural resources and what we can help to benefit. Once again, let's talk about the aircraft and sensor consideration for natural resources. Some of these are going to be somewhat similar because we want to make sure we fly long flight times, because like land surveying, like you'll see in precision agriculture, these sites can be very large, oftentimes hundreds or thousands of acres. LiDAR sensor accuracy, that's going to be an important one, because oftentimes with natural resources, we are looking for deliverables such as a digital terrain model. And we want to be able to find anything within that digital terrain model and have it be accurate. So with that, we want to make sure that our LiDAR sensor is accurate, long transmission range, as well as really good transmission quality so that you can maintain safe operations, even if you have a lot of vegetation around, and being able to work in robust work environments where it may be very hot, may be very cold. You may even have to be surveying during rain, or if it's something with disaster response and you need to get out there right now to start documenting. When we look at the surveying solutions, very similar, once again, to the surveying side, we're going to be utilizing the Mavic Enterprise series as the most scalable, affordable drone surveying solution that we have to offer, mainly with a large sensor size for the platform, as well as having accurate image tagging and accurate image capture with a mechanical shutter. Also with the Matrice series, getting into that versatile payload, being able to change out and capture that LiDAR data when needed, because oftentimes a lot of these job sites are going to have dense vegetation. Also, we would need to be able to change out for something that would be a multispectral sensor. And that includes on the Mavic 3 Enterprise or Mavic Enterprise series, where we may have a multispectral version that you'd want to utilize rather than a traditional just mapping. And then we have the software to be able to process that. That would be DJI Terra. And finally, on the use case side, when we look at natural resources, diving back into the benefits of utilizing UAS across the site planning, site documentation, recovery, you can see the different use cases where drones can be beneficial. So site assessment, understanding drainage within that site, site documentation for elevation mapping, environmental monitoring, tree classification, habitat monitoring, as well as recovery, getting into emergency response and site progression analysis, just to name a few. When we get into the case studies, let's take a look first at forest growth monitoring. Being able to cover something like this, a 300-acre forest on foot, is going to be very challenging. Covering it with manned aircraft is going to be very expensive. And so finding that nice balance of utilizing a affordable solution like a Mavic multispectral series, where you're paying a few $1,000s to really start capturing really dense data. And then from here, we can create plant health maps, understanding what areas of the forest maybe have the most amount of stress that we're going to go back out, understand if we do have any specific disease that needs to be addressed. We also get into forestry mapping and understanding quantity when we get into individual tree segmentation. This can be done with something like the DJI Matrice series, and we would recommend utilizing LiDAR if you are trying to do individual tree segmentation. Just being able to build a very dense point cloud and getting multiple returns is something that we can then run it through third-party solutions that you're going to be able to do this type of analysis. DJI is going to mainly get you all of the data, hardware and software wise, where then you can analyze it and turn out a deliverable, such as this forestry mapping use case here, where we're able to really understand what the density is. And for another one, this is one that I'm really excited about, is we were able to capture data in Guatemala. We were looking for ancient Maya ruins. And with that, capturing with the Matrice series, the LiDAR payloads that DJI manufactures, this is very dense jungle. This is also very remote area, and it would be something that would be incredibly dangerous for someone to walk on foot and try to measure this. Also, when we're looking at some of these extreme environments, what happened previously when it was contracted, this very large site within the Yucatan Peninsula, the actual manned aircraft was not able to finish the job, and it went down, and it was a very costly and expensive mistake. And so utilizing drones is where you can bring some of that safety as well as some of the risk down comparatively. Even though we may not be able to capture as much, we're getting much more dense data and a much safer work environment. Utilizing 4 matrices at one time and utilizing LiDAR sensors and DJI Terra to be able to process all of that data. And finally, let's talk about that final industry within this training, which is precision agriculture. As we walk through the introduction of precision agriculture, that utilizes technology to help aid a grower in either producing higher yields while maintaining a healthy ecosystem. These different technologies within precision agriculture can include guidance and auto steer for tractors, combines, sprayers, different types of equipment. It can talk about yield monitoring, so we understand exactly what's coming out of the field so we can make management decisions for next year. We can also do soil sampling, where you'll be driving around the field, oftentimes on a UTV or ATV, and plunging holes into the ground, taking soil cores, and then getting those tested to understand what the nutrient deficiencies may be. Also, we get into vegetation mapping, being able to fly over it with manned aircraft or drones, or even utilizing satellite data. When we looked at the different roles and responsibilities within precision agriculture, it's not just about a farmer here but for personas, but this can be an agronomist, this can be a landowner, this can be a co-op. But we walk through the process of early in the season with trials and planning. As we get that growing season going, we got to get the seed in the ground if it's something that we're typically planting. Something that my experience has been is mainly with row crops. And then as we get into in-season, monitoring that crop and then harvesting that crop out. And you can see there are a number of different responsibilities that a grower or someone may need to make within the growing season every year. We also have a number of different personas within precision agriculture. We have the actual commercial production grower of the crop. We may have a plant scientist that's going to be doing breeding and genetics to be able to produce the seed for the commercial production grower to grow. Then we have a crop advisor that's going to be an agronomist that's going to be making management decisions or helping to make management decisions with their expertise in crop science. Also the seed and chemical salesperson, so the seed that was developed by the plant scientist needs to be sold through a dealer network typically, so we have that seed and the chemical salesperson that's giving their perspective. The insurance provider, oftentimes we have crop insurance and understanding after a significant event. An insurance provider, one of those really important personas within drones for precision agriculture because you can cover a lot of ground very quickly. Also, livestock management. We're not just talking about crops here, although I like to go on a tangent sometimes. And next, let's talk a little bit about the challenges within the precision agriculture industry. First off, it's very seasonal. You're going to be going every year. Generally, you're going to be having one crop. You may have 2 or 3 crops depending on what territory you're in, but it's very seasonal work. Also, there are many different roles and responsibilities for growers. So growing crops is not just about putting a seed in the ground. That can be equipment maintenance. It can be a number of different things just to manage a farm. Also, it can be very weather dependent. We all have seen that before. Also, large scale. A lot of these crop ground is going to be, dozens, if not hundreds of acres per field. And also very low connectivity, very rural areas that we're looking at. We get into the workflow of what a traditional agronomist or a crop advisor or even a grower is. That would be an agronomist checking a few random, or maybe not random, locations within a cornfield if they've been there before. And this is just an example for corn. These fields can be very large, and it's going to be just checking a number of different quick locations. It's very hard to get perspective. As crops grow taller, we can't see above the canopy. It can also be very difficult to navigate to the center of the field and get perspective of where we are at, where we are measuring, and where we're looking at crops. All the responsibilities, so agronomists are not just going out and checking on fields, they typically are also being salespeople as themselves, trying to sell seed, chemical, whatever that may be. Also being able to manage different growers at one time, so they're not just working with one individual grower, and also decisions you made in a very timely manner. So we're talking about herbicide, fungicide, pesticide decisions when we're applying. We're talking about fertilizer recommendations. A lot of those need to be flown, processed, analyzed, and understood and made a management decision within days, because each day that yield potential may be lost. The benefits of utilizing UAS, once again, very similar to surveying and mapping and natural resources, getting more clarity over very large areas that we've been talking about. It's also being able to prove to growers the adoption of technology. So if you are trying to sell something, whether it's seed or chemical dealer, you can kind of show that the grower, hey, I'm adopting technology, I'm utilizing something that's going to help benefit making decisions for your farm. Also the data quality, we're looking at very dense data comparatively, whether it's just boots on the ground or even when we're looking at satellite or with cost, manned aircraft imagery. So being able to understand down to every square foot, every square inch on that field. When we get in the DJI solution and what to look for precision agriculture, very similar here when we look at RTK image tagging, high quality shutter, as well as a large sensor. But we do need to look at sensor wavelength accuracy. So when we're looking at near infrared bands of light and red edge bands of light, where we see the biggest differential between a healthy and a stressed plant, we need to be able to take that image very accurately within that reflectance or within that band of light within the electromagnetic spectrum. So right around that red edge, near infrared, we're looking for very accurate wavelength accuracy so we can see the difference between a healthy and a stressed plant. Also long flight time covering large of area and long transmission range. We may be flying fields that are very far away from us, the other corner of the field. So we need to have long transmission range and also large data storage. Multispectral can be very dense data. Looking at hardware and software, my face is kind of covering up the Mavic multispectral line, but we do have the ability of capturing multispectral, something that we build in-house. It's also going to be about the most affordable, scalable solution for multispectral capture when it comes to precision agriculture. We also have the Matrice line. If you are looking to do something with higher resolution photogrammetry, if you're looking to do LiDAR, that can be very common, even in our area where we have, in Iowa, where we have subsurface drainage and we need to understand where water is draining off the field. We need to capture LiDAR so that we can be able to put that subsurface drainage where it really should be. So looking at the Zenmuse L and the P series for capturing the highest quality photogrammetry and LiDAR possible, and then processing that data within something like DJI Terra or even DJI Smart Farm. And then let's wrap up with some of the different use cases within precision agriculture, diving back into the benefits of using UAS and the growing season itself. So from trials and planning to planting to in-season and harvest. You can see there are a lot of different use cases here for precision agriculture, whether it's trial plot planning, making purchasing decisions on seed, on fertilizer, on chemical, also planning drainage and irrigation. As we get into the growing season, understanding planting and growth and emergence of that crop, understanding if it's needing any sort of fertilizer to get it going, understanding disease, pest, and weed detection and management, and then in-season harvest is going to be repeated flights. We're going to be looking at agronomic purposes if we need to be putting on any sort of fertilizer or attacking any sort of pest or disease. Also insurance claims when we're looking at those weather events. The very first case study that we have here, microplot monitoring, this is definitely a home run when it comes to precision agriculture, where you may have a microplot farm where they have dozens, hundreds, if not thousands in this instance, because the plots are so small, of different tests that are going on. It may be different varieties of seed. It may be different rates of fertilizer. It may be different chemicals comparative to a just non-sprayed versus sprayed area. So they're being able to document with extreme data density, as well as document hundreds or thousands of these within 1 or 2 or 3 flights. And then also with the image accuracy, being able to walk directly back out to that same plot and ground truth it and know you're at the right location. This was captured using the Mavic multispectral series, so even a very affordable, scalable solution drone. And then from here, we can run it through third-party data analysis tools to understand which plot is performing the best. We can also talk about orchard management. It isn't always about row crops. So being able to fly over a field and look at each individual tree, understand if each individual tree has any disease, and then make a management decision tree by tree basis. Also, it's very hard to get perspective when you're in an orchard and having imagery that's very accurate. You can go directly back out to that exact same tree and know you're there. So the density as well as the accuracy here is going to help orchard management. Also, the repeatedness, being able to fly this weekly and understand the changing environments and being able to stay on top of any disease pressure that may be coming. We also have one here for cotton production. This was more around germination and being able to take really high resolution visual photos as well as multispectral photos, we can give an estimation of what that emergence is, and you can see the different dots on the bottom, so we can more or less take sampling of the field rather than trying to stitch the entire field. And that high resolution sampling, we can run AI or machine learning on that to give you what a germination rate would be. So then we can go and check in those areas of the field where that may have a lower germination rate on the individual image, and then understand if we need to go back in and replant in those areas if there's enough of a yield hit potential from emergence. Once again, captured with that DJI Mavic multispectral series. And finally, we have one more with spot spraying weeds. This was something that I was able to do a couple growing seasons ago, being able to fly over a field and utilizing third-party analysis tools to detect weeds. This was, example, a volunteer corn plants within a soybean field. So the previous year's corn plants that started growing again after harvest for the next year. So we were able to go in and fly a multispectral drone very low, understand and highlight with that third-party solution where each one of the corn plants is, and then from there, instead of spraying herbicide on the entire field just to kill some of the weeds that are out there, we can use and load the prescription into a spray drone or even a ground-based sprayer and then spray just those plants and save an affordable solution there when we're saving on the input costs. So we spend a lot less on chemical, and then also we are, by utilizing a DJI drone like an Agris line, you're going to save on soil compaction, not having to drive through the field. So, and yield potential where we were able to spray and kill those weeds that were taking some of the nutrients away from the actual soybeans that we were looking for. So once again, the entire drone ecosystem, DJI ecosystem, working together for that use case. Thank you all for that training. If you have any questions, feel free to reach out to us, and we look forward to seeing you on the next Geospatial training course.